Okay, well, this is chapter 1, which you can see from the title there, is about the importance of MIS. This is largely an overview chapter. We're going to talk about why Business 391 is an important class to take. We're going to talk about how information systems have shaped society. We're going to talk about some very high-level concepts, many of which we'll talk about in more detail as we get into some of the later chapters and things. But this will be just a brief introduction. We're going to go pretty quickly through most of the concepts here. But I think it'll be a good time, and I think it'll give you a nice sense for how this class is going to be shaped. One of the things I'll try to do today is highlight the topics that we're going to go into in more detail later on. And so you'll see there'll be some things that we'll spend a little more time on, some things not quite as much time on, but I think you'll get a sense as we go along. I've got my iPad here with my pen, and so I'll do some markings and things as we go along. Let's see how things go. Let's start with a very important question. Why is it important that you take this class? I know many of you are in this class because you're required to. And so you're probably facing the question, why am I here? What is the point of taking this class? What's the purpose behind it? And the very simple explanation to why this class is so important is because information has fundamentally changed businesses. Information, and then by extension, technology. Businesses are different today than they were 5 years ago, than they were 20 years ago, than they were 50 years ago, and technology has played a huge role in doing that. We're in the midst right now of what many refer to as the information age. What that means is that information, while it's always been incredibly important, the value of information has increased dramatically within the last, I'd say, probably 20 or 25 years, or thereabouts. Take, for example, I've got a link to a YouTube video down there talking about Facebook. Facebook has more than 1 billion users across the planet. They're one of the richest companies in the world, and yet their main product, Facebook, is free for just about everyone. And so the question is, well, how on earth do they make money? The way that they make money is through advertising, and the reason why their advertising is so valuable is because of the information that they have. This is true not only for Facebook, but also for Google, also for Amazon, also for a tremendous number of companies that exist today. The information age is centered around the idea that information has become the currency of today's business world. And so, if we want to understand not only how that came about, but also how we can use information in today's world, there's a lot of different topics and things that we can explore along the way. Well, how did this happen? How did we get to this point? There's a lot of forces that led to today being kind of described as the information age, or all of the new technologies that have come about recently. We're going to talk about a few different laws, and they all have different names. This first one here is Bell's Law. Bell's Law is very simple. It's not mathematical in any regard, but it says that every decade we get a completely new class of computers. And by class of computers, we don't just mean faster computers. We mean completely different breed of technology. If the 2000s were marked by smartphones, not that necessarily, the first smartphone came about in the 2000s. Wow, I wrote the 200s. That's hilarious. But they became incredibly more popular, incredibly more utilized during that period of the mid to late 2000s, and that really dominated that decade. It's a technology that wasn't heavily utilized much before. In the 2010s, we saw a few things. We saw smart technologies, smart devices. Nowadays, we have smart refrigerators, we have smart sprinkler systems, we have smart doorbells, different things, and those really were popularized in the 2010s. I would also add, and this is something that's even trending into the 2020s, is what we call augmented reality. We're going to talk about smart devices, and we're going to talk about augmented reality a little more in Chapter 4, which we'll get to later on this week. But the idea here is that every decade, we're not only increasing the speed and the efficiency of the devices that we already have, we're coming up with completely new devices. And so it's important not only to understand how today's technology works, but also to understand how technology works in general so that you can be prepared for whatever may come as we enter into a new decade. And as you enter into, that's a terrible question mark, but you get the idea, as we enter into decades to come. So that's Bell's law in a nutshell. There's also a lot of other different forces. One of them is called Moore's law. Moore's law is a little bit more mathematical, a little bit easier maybe to follow from a mathematical computing kind of sense. But the idea of Moore's law is that computing power doubles every roughly 2 years, every 18 months to 2 years. Okay? And they actually go a little bit beyond just kind of computing power. They talk about this idea of price performance ratio. So if you took a computer processor that cost the same amount 5 years ago as it does today, so a processor that you could get for, let's say, $50. A $50 processor 5 years ago versus today, today's $50 processor is dramatically more powerful than that processor even 5 years ago. And we've seen this in a number of different ways. This has been an incredibly accurate law to follow. It came about, I think, in the 60s or 70s, somewhere in that time frame. And what we've noticed over time is that this has held true, that the computing power has dramatically increased. It goes up, it doubles roughly every 18 months or thereabouts. And what that does is that allows people to be able to predict where technology is going. And so we can look 10 years, 20 years into the future, and we have a decent idea of how fast technology is going to be by that point. It allows people to start working on technologies now that won't even be used until 15, 20, 30, 50 years from now. It's really incredible what this law allows us to be able to do. So we've got one law talking about a completely new type of device and the innovation there. This is mostly talking about existing devices, but them increasing in speed while reducing in cost, things like that. Another law is referred to as Metcalfe's law. Metcalfe's law talks about the value of networks. And so this is something that we've seen a lot as social media has come about, is the idea of connecting people together. Well, the more people you connect together, the more valuable that network becomes. And it's an exponential increase. You see the direction of the curve here is exponential. And so when you have two people in a network, it has a certain value. When you add one more person, you're not just adding one to the value of the network, you're adding one to every person within that network. And so it's increasing. The difference between 3 and 4 increases and increases and increases. And so one of the reasons, just to kind of highlight this bullet point here, one of the reasons why these social media networks are so incredibly valuable, why Facebook is worth billions and billions and billions of dollars, is because they have so many people and they're able to exploit the value of those networks. One more for you. So we've got Bell's law, we've got Moore's law, we've got Metcalfe's law. Now we're talking about Kreider's law, which is very similar to Moore's law. Moore's law deals with processing power. You'll learn more about this when we talk about hardware and software on Thursday. This is Kreider's law, which talks about storage capacity. It's a similar concept, that as we increase in time, the price of storing, you see underlined up here, decreases every single year and keeps on decreasing and decreasing and decreasing. You know, if you go back 10 years ago and you look up how much just let's say a 256 megabyte little thumb drive, how much that costs versus today. Today, people just give those away for free. Not just 256 megabytes, multiple gigabytes in just a simple little thumb drive. And people will just give those things away like they're absolutely nothing. What this says is that as we project out in the future, the price of storage is decreasing. And that's really important because the amount of information that we're storing is just increasing dramatically every single day. And so this becomes incredibly important. So we've got a lot of these different laws. You see there Moore's, Metcalfe's, Nielsen's law, Kreider's law. There's all kinds of different laws that come about. There's more. We could talk about one called Zipf's law, ZIPF law, which is another instance talking about the value of a network. There's all kinds of different laws that have come about. The major point here is that technology is increasing rapidly. It's affecting many different areas. And so if our only goal in this class was to understand how technology works today, then 5 years from now, all of that is going to be completely outdated. You'll be completely unprepared to enter the workforce or to get started within your career if all we do is learn how technology is right now. What we need to do is understand the forces surrounding technology so that we can predict where they're going, so that we can understand how things are going to look 5 years from now, 10 years from now, 20 years from now, so that you'll be better prepared for whatever career that you want to enter into. So one of the major things that we're going to learn in this class is not just how technology works, but also all of the things surrounding technology and how they might impact the way in which we go about the world. Okay, so in this class, in Business 391, we're not just focused on how technology works, but also focused on where technology is going and how we can use technology in so many different ways and things. It's more about how we use technology than it is necessarily about how it works. But in order to understand how to use technology, we have to understand how it works too. So we'll get a little bit of both of those things. Now, let's get a little bit more personal with things. So we talk about the forces shaping technology in general. Well, how does MIS, Management of Information Systems, how does that affect you individually? Let's talk about a couple different things. So we've got all these different laws that talk about the acceleration of technology and things that are advancing. Well, one of the major questions you might be asking is, well, how do I have job security in a completely changing, rapidly changing world? Okay, if your entire skill set is something that is incredibly routine, it can easily be outsourced or it can be completely replaced by technology. Technology is increasing to the point that a computer is almost as advanced, almost as fast as the human brain. We're getting closer and closer and closer. And so if all you're doing is something that a computer could easily replace, then where does that job security come from? And so what we're trying to get to, what we're trying to understand, or what we're trying to build in you are skill sets that extend beyond something that technology can easily replace. For example, here's some what your book calls non-routine skills. You talk about abstract reasoning, systems thinking, collaboration, the ability to experiment and try different things. These are difficult for technology to replace. And we can build these skill sets and we can help you understand not only how to build them abstractly, but also how to use technology or how to incorporate them into technology in whatever career path that you want to go into. Let's talk about each one just real briefly, and I'll talk about how it's going to apply to our class. One skill set that is non-routine, that's not easily replaced by technology, is abstract reasoning. Taking difficult concepts, coming up with what we call a model of that concept, basically trying to take a lot of information and then coalesce it into something that can easily understand. One of the major things that we're going to do in this class is we're going to learn about databases and how they work. And one of the first things that you do in constructing a database is you take all of the data that you need to gather and you build it into a data model. You see here. And a data model represents kind of an abstract view of here's what all of the data looks like and how it's going to be organized. That's not something that can be easily replaced by technology. The ability to look at a large data set and figure out, okay, well, this is kind of like this, and this is kind of like this, and these tables need to go together like this. That's a skill set that can't easily be replaced. And it's incredibly, incredibly valuable. So when we get into talking about databases pretty soon, one of the things we're going to learn is this abstract reasoning and the ability to model data in that way. Another concept we're going to learn is what we'll call systems thinking. The ability to take a lot of different components and connect them all together to build out a system in that kind of regard. Okay? one of the major things we learn in information systems is how systems operate. We've got hardware, and we've got software, and we've got people, and we've got procedures, and all of these individual components combine together to form an information system. Well, recognizing that, understanding how that works and how it can be applied, that's not something that can easily be replaced. If you've got that skill set, you've got a lot of value that you can offer to an organization. Collaboration, okay, the ability to work together with people, the ability to deal with difficult people. You're going to work in this class on a group project that involves a heavy degree of collaboration. It's going to be incredibly important to learn and to do well. And so we're going to work on collaboration a little bit together. And then this concept of the ability to experiment. We're going to learn Microsoft Excel in this class. We're going to learn Microsoft Access. But one of the things that I want to teach you beyond just how these two software programs work is how to tackle a problem when you don't know exactly how to come up with a solution. We'll learn, like in Excel, I'll teach you a number of different functions. And those functions will be great, and if you have a problem where that one of the functions that we learn in class is the one you're supposed to use, then great. Then it's pretty easy. I know what this function is. I can apply it to this situation and go. The challenge is what happens when you're facing a problem and you don't know which function you're supposed to use. When you've got to come up with something entirely on your own. So we're going to try to learn that in this class and develop that skill set. How do I take what I already know? How do I learn more and then combine that together to figure out how to solve a problem? It's difficult to do. It's not an easy thing to come up with, but it's a skill set that we're going to learn. And we're going to learn it through using technology in this class. Okay. So those are some of the skills that we're going to develop alongside learning about how technology works and how it can be used in businesses and things. The goal of which is to make you more marketable, to present you in a way that you can walk into a job day one and you've got a skill set that cannot easily be replaced by buying a new software package or a computer that comes out on the market. The next thing that we're going to learn, or the next question that we're going to address is, what is MIS? This is continuing on our theme of the overview here in Chapter 1. What is an information system? Okay. This is a question we're going to be addressing throughout the entire course, but in a nutshell, we can define an IS as kind of a combination of a lot of different things. There are many different components, and your book kind of keeps this 5-component framework throughout. So you see the 5 here: hardware, software, data, procedures, and people. On Thursday this week, we're going to talk about those first 2, hardware and software. We're going to define them. We're going to talk about how they impact information systems and things going forward. Then we'll get into the data piece. We'll talk about a database and how we organize data and what data can be used for. Okay, it's not the only time we're going to talk about data in this class, but it's the time we'll talk about it most specifically. Procedures are the business side of things. So what are we building an information system to do? Are we building it to help us select better job applicants, or choose a marketing strategy, or organize all our company's finances, etc., etc., etc.? Those would be the procedures piece. And then the people piece is something that we don't want to lose sight of, is recognizing that an information system requires a human to use it, a human to develop it, a human to build it, things. So we're going to keep the people side of things along the way. And that's the major point of this next slide here, talking about the difference between an information technology and an information system is recognizing the human intervention in there. Okay? A technology without people is just sitting on a shelf somewhere, but when it is used by people to do things within an organization to help with certain procedures, then it becomes tremendously valuable in that way. Okay? So what do information systems do? Well, they exist to help people achieve business objectives. That's a very broad term. It doesn't really mean much in and of itself, but it's designed to be broad because information systems can be used for a variety of different forms. I like to think of it as helping us to answer questions or helping us to solve problems. Every business faces problems, has questions, is trying to achieve certain outcomes. Systems are designed to help people achieve outcomes. They're tools that are used in that kind of way. Okay? So that's kind of in a nutshell what an information system is. We can delve a little deeper and talk about what is information. I mean, the difference between data and information. Okay, data is nothing more than recorded facts or figures, just numbers, or just images, or just text by itself. Okay, if I give you the number 27, that would be data. Or if I say that Mary Jones here earns $50 per hour, that's just a statement of fact. In that kind of way. It doesn't really do much for us unless we have a context in which to add it in. Okay, so data by itself is just a recorded fact. Well, what is information? Information is when we use that data to do something. So when we take that piece of data, we recognize that, let's go back one, Mary Jones earns $50 per hour. If that's in a situation where we're trying to determine the efficiency of our employees, then knowing that Mary makes $50 per hour is beneficial to us. If we're trying to figure out the cost of a project that Mary is working on, knowing that Mary makes $50 an hour, that's beneficial to us. That's something that we can use in that kind of way. So that's the gist of the difference between data and information. Data is important. We want to know how we can organize it and store it, but being able to use that information in order to solve business problems, that's what makes it information. Okay. So like if I gave you this chart and I took a lot of data, but I gave it a context, so all of these numbers here, the stock price and net income of Amazon over a long period of time, by itself, this is a lot of data, but when I'm using this in order to maybe predict where Amazon is headed in the future, that then becomes information in that kind of way. Okay, so the graph by itself is not information, but when I use it in a certain way, then it becomes information in that sense. The major point here is that we're not gathering data and organizing it and storing it just for its own purpose. We're gathering and storing that information so that we can use it. We're not learning about computers so that we understand how this box works and how a processor works and what memory does just for its own sake. We're learning those things so we can understand how we can use them to solve business problems. The major point of Business 391, of understanding information systems, is to understand how we can use technology in order to solve business problems. If you think about it, right now, we are in the midst of a business problem. How do we deliver information to students that are scattered all over the state, all over the country, all over the world? And what I'm trying to figure out as an educator, and what our university is trying to figure out, is how can we best educate our students in this unique situation. And so I'm trying to figure out the way to use as much technology as I can. I've got an iPad and a pencil so that I can mark things and give you more dynamic content. I'm using my laptop. I've got a microphone here so that I can record information and then disseminate that to you. This is using technology. This is understanding technology so that we can use it to solve a business problem in that way. And I think one of the things that may come out of this quarter in the unique situation that we're all in is trying to see how understanding technology and how it works can help us respond to dynamic situations like this. So I'm excited for this quarter. I'm excited for sharing this content with you. I'm excited to help teach you how technology works and how we can use it. And I'm hopeful that even in the midst of these challenging times, that we're still able to connect together and understand this stuff a little bit better. So that's chapter 1. We'll go move on to chapter 4 next and talk about hardware and software.